Welcome back to ChemHelp ASAP. We're going to do a quick bonding orbital picture for formaldehyde. Now, formaldehyde, if you've watched these videos sequentially as a playlist, formaldehyde is really very similar to ethylene. So we have formaldehyde on the screen as a Lewis structure. This carbon is sp2 hybridized. It's going to have bond angles of 120. It's going to be trigonal planar. And so let's draw this structure. Once again, I'm going to remember when we say sp2, we're going to take 3 of our atomic orbitals, an s and 2 of the p's. We're going to get out 3 sp2 hybrids plus a leftover p orbital, in this case pz. So let's draw this picture. The carbon is going to be bonded to an oxygen. I'll take care of that in a second. Also has sigma bonds to both those hydrogens, and this carbon is going to have a leftover unhybridized p orbital, and I've said it's going to be the pz. So now we have this bond to oxygen. In order to make a second bond, a pi bond, to the carbon, this oxygen also needs a p orbital in the same orientation as carbon. So this must be a pz. Now, in previous videos, I've said technically terminal atoms, we don't have to worry about hybridization, but this oxygen is going to force our hand. We need to talk about its orbitals. So people say, what the heck? Give those lone pairs, put them in hybrid orbitals, and let's complete our picture. So if we can't give the lone pairs hybrid orbitals, we're going to need 3 hybrids for oxygen, 1 to make the sigma bond to carbon, and 2 hybrid orbitals to hold the lone pairs. These are going to be in a planar kind of setup again. Because, again, if we go sp2 for oxygen, x, y, and z, we know that pz has to be left unhybridized. So if we do sp2, we must be using hybrids in specifically the x, y plane. So we'll put our lone pairs in hybrids that sit in the x, y plane. Now we complete our 2 interactions there. Again, we're trying to show that all the hybrids sit in the xy plane, and we have the pz orbitals. But this is how you show lone pairs in these orbital pictures. You put them in lobes, typically they're hybrid lobes, and we have them coming off the atom consistent with the geometry that the hybridization would require. So that very quickly is the bonding picture, the orbital bonding picture for formaldehyde.